Welcome to the Podlets podcast.
Hello and welcome back to the Kubelets podcast. My name is Nicholas Lane, and this time we're going to be talking about the dichotomy of security. And to talk about such an interesting topic, joining me are Duffy Cooley.
Hey, everybody.
Brian Lyles.
Hello.
And Carlicia Campos.
Glad to be here.
So, how's it going, everybody?
Great.
Yeah. So this, I think, is a interesting topic. Duffy, you introduced us to this topic, and basically, from what I understand, what you wanted to talk about is we're calling it the dichotomy of security because it's the relationship between security, like hardening your application to protect it from attack and influence from outside actors, and the agility to be able to create something that's useful, right? The ability to iterate as fast as possible.
Exactly. Yeah. I mean, and actually, the idea for this came from putting together a talk for a security conference coming up here in a couple of weeks, and I was noticing that, like, obviously, if you look at the job of somebody who's trying to provide some security for applications on their particular platform, whether that be AWS or GCE or OpenStack or Kubernetes or any of these things, it's frequently in their domain to kind of define constraints for all of the applications that would be deployed there, right? Such that you can provide rational defaults for things, right? Maybe you want to make sure that things can't do a particular action because you don't want to allow that for any application within your platform. Or you want to provide, some constraint around quota or all of these things. And some of those constraints make total sense. And some of them, I think, actually do impact your ability to design the systems or to consume that platform directly, right? Like you're not able to actually make use of the platform as it was designed to be made use of when those constraints are too tight.
Yeah, I totally agree. There's kind of a joke that we have in certain tech fields, which is the primary responsibility of security is to halt productivity. That isn't actually true, right? But no. There are trade-offs, right? And if security is too tight, you can't move forward, right? Some things I come to mind, examples of this I come to mind are like, if you're too tight on your firewall rules, where you can't actually use anything of value, that's a quick example of like security gone haywire. It's like that's too controlling, I think.
That's a great. Go ahead.
Actually, this is a interesting topic just in general. But I think that before we fall prey to what everyone does when they talk about security, let's take a step back and understand why things are like the way they are. Because all we are talking about are the symptoms of what's going on. And I'll give you one quick example of why I say this. Things are the way they are because we haven't made them any better. In developer land, whenever we consume external resources, what we're supposed to do and what we should be doing, but what we don't do, is we should create our own internal interfaces, only program to those interfaces, and then let that interface or that adapter talk to the external service. And in the security world, we should be doing the same thing, and we don't do this. So my canonical example for this is IAM on AWS. It's hard to create a secure IAM configuration, and it's even harder to keep it over time. And it's even harder to do it whenever you have 1, 50, 100, 5,000 people dealing with this. So what companies do is they actually create interfaces where they can describe the part of IAM they want to use, and then they translate that over. So the reason I bring this up is because the reason that people are scared of security is because security is opaque. And security is opaque because a lot of people like to keep it opaque, but it doesn't have to be that way.
That's a good point. And that's a reasonable design. And where I've seen that deployed, it actually is very helpful, right? Because the people, I think it's, you highlight a critical point in that if you're going to, these constraints have to be understood by the people who are constrained by them, right? Or it'll just continue to kind of like drive that wedge between the people who are, in responsible for defining them and the and the people who are being affected by them, right? And so that transparency, I think, is definitely key.
Right. So I guess this is our cloud native discussion. So any idea of where we should start thinking about this in cloud native land?
So I think, and for my part, I think it's important to understand, if you can, like where, what the consumer of a particular framework or tool might need, right? And then to take it from there and figure out what rational constraints are, rather than the opposite, which is frequently what I see, where people go and evaluate a set of rules as defined by some particular, some third-party company. Like you look at CIS specs, and you look at like a lot of this other tooling. I feel like a lot of people look at those as like these are the hard rules. We must comply to all of these things, and legally, in some cases, that's the case. But frequently, I think they're just kind of like casting about for some semblance of a way to start defining constraint, and they go too far because they're no longer taking into account what the consumers of that particular platform might need, right? And Kubernetes is a great example of this. If you look at the CIS spec for Kubernetes, or if you look at a lot of the talks that I've seen kind of around how to secure Kubernetes, we define like best practices for security, and a lot of them are incredibly restrictive, right? And I think that the problem there is that like that restriction comes at the cost of agility. You're no longer able to use Kubernetes as a platform for developing microservices because you've provided so much constraint that like it breaks the model,
Okay, so let's break this down again. So I can think off the top of my head 3 types of things people point to when I'm thinking about security. And spoiler alert, I am going to do some acronyms, but don't worry about what the acronyms are. Just understand that they are security things. So the first one I'll bring up is FISMA, and then I'll think about NIST, and the next one is CIS, like you brought up. And really, the reason they're so prevalent is because depending on where you are, whether you're in a highly regulated place like a bank, or you're working for the government, or you're just, or you have some kind of auditing concern, let's say of HIPAA or something like that. These are the words the auditors will use at you. And there is good in those because people don't like the CIS benchmarks because sometimes we don't understand why they're there. But from someone who is starting from nothing, those are actually great. There's at least a great set of suggestions. But the problem is you have to understand that they are only suggestions, and they are trying to get you to a better place than you might be. But the other side of this is that we should never start with NIST or CIS or FISMA. What we really should do is our CISO or our chief security officer or the person in charge of security, or even just our people who are in charge of making sure our stack, they should be taking what they know, whether it's the standards, and they should be building up this security posture and this security document and these rules that are built to protect whatever we're trying to do. And then the developers or whoever else can operate within that rather than everything, literally.
Yeah, agreed. Another thing I've spent some time talking to people about, like when they start rationalizing how to implement these things, or even to think about the secure surface or develop a threat model or any of those things, right? One of the things I think that's important is the ability to define kind of like what normal looks like, right? What normal access between applications or normal access of resources looks like. And I think that your point earlier, like being able to provide some abstraction in front of a secure resource such that you can actually just share that same abstraction across all the things that might try to consume that external resource is a great example of that. Defining what that normal access looks like is critical to us, to our ability to constrain it, right? And I think that frequently people don't start there. They start with the other side. They're saying, well, here are all the constraints. You need to tell me which ones are too tight. You need to tell me which ones to loosen up so that you can do your job. You need to tell me which application needs access to which other application so that I can open the firewall for you, right? And I'm like, we need to turn that on its head. We need we need environments that are perhaps less secure, so that we can actually define what normal looks like, and then take that definition and move it into a more secure state, perhaps by defining these across different environments, right?
So a good example of that would be in larger organizations. Not every larger organization does this, but there's environments for running your application where there are really no rules applied. And what we do with that is we turn on auditing in those environments. So you have two applications or a single application that talks to something, and you let that application run. And then after the application runs, you go take a look at the audit logs, and then you determine at that point what a good profile for this application is. So whenever it's in production, you set up the security parameters, whether it be identity access or network, based on what you saw in auditing in your pre-production environment. And that's all you can run, because we tested it fully in our pre-production environment. It should not do any more than that. And that's actually something I've seen tools that will do it for AWS IAM, and I'm sure you can do it for anything else that creates auditing logs. So that's a good way to get started.
So it sounds like what we're coming to is that the breakdown of security, or the way that security has impacted agility, is when people don't take a rational look at their own use case, instead rely too much on the guidance of other people, essentially, like following, instead of like using things like the CIS benchmarking or NIST or FISMA. That's one that I knew the other two, and I'm like, I haven't heard this other one. If they follow them less as guidelines and more as like hard set rules, that's when we get impacts for agility. Instead of like, if you're like, hey, this is what my application needs, like you're saying, let's go from there. Like, what does normal look like, Duffy, as you're saying? I'm kind of curious. Let's flip that on its head a little bit. Are there examples of times when agility impacts security?
So you're saying you want to move fast, and moving fast is counter to being secure?
Yes.
Well, yeah, literally every single time we write software.
Yeah.
So what it comes down to is developers are going to want to develop, and then security people are going to want to secure. And generally, and I'm looking at it from a developer who has written security software that a lot of people have used. You guys didn't know that. Really, there needs to be a conversation. It's the same thing as, like, we had this DevOps conversation, having this DevOps conversation for a year. And then over the last couple of years, this whole DevSecOps conversation has been happening. We need to have this conversation, because from a security person's point of view, no access is great access. No data, you can't get owned if you don't have any data going across the wire. You know what? Can't get into that server if there's no ports opened. But practically that doesn't work. And what we find is that there is actually a failing on both sides to understand what the other person is optimizing for. So that's actually where a lot of this comes from. But I will offer up that the only default secure posture is no access to anything. And you should be working from that direction to where you want to be, rather than working from, well, what should we close down? No, you should close down everything. And then you work with allow lists rather than block lists.
Yeah, I agree with that. I agree with that model, but I think that there's an important step that has to happen before that, and that's the tooling or the wherewithal to define what the application looks like when it's in a normal state or in a running state. And if we can accomplish that, then I feel like we're in a better position to find what that allow list looks like, right? And I think that we spend one of the other challenges there, of course. Like let's back up for a second. Like I have actually worked on a platform that supported many services, hundreds of services, right? Now, clearly, if I needed to define what normal looked like for 100 services or 1,000 services or 2,000 services, that's going to be difficult in the way that people approach the problem, right? Like, because like, how do you define normal for each individual service? I need to have some declaration of intent. I need the developer to engage here and tell me, like, what they're expecting, to set some assumptions about the application, like what it's going to connect to, its dependencies are, that sort of stuff. And I also need tooling to verify that. I need to be able to kind of like build up the whole thing so that I have some way of automatically, maybe with oversight, defining what that security context looks like for this particular service on this particular platform. Trying to do it holistically is actually, I think, where we get into the trouble, right? Like, obviously, we can't scale the number of people that it takes to actually understand all of these individual services. We need to actually scale this as a software problem instead,
Right.
which is...
So,
And we shouldn't be. Oh, go ahead, Carly.
so with a cloud native architecture and infrastructure, I wonder if it makes it more restrictive, because everything, let's say things are running on Kubernetes, everything is running on Kubernetes, things are more connected because, anyway, it's a Kubernetes, right? It's this one huge thing that you're running on, and Kubernetes makes it easier to have access to different nodes, and within the nodes to different pods. Of course, you have to define those connections, but still, it's supposed to make it easier. So I wonder if security, as from a perspective of somebody needing to put restrictions, an admin, for example, it makes it harder, or if it makes it easier to just delegate. Okay, you have this entire area here for you, and as long as you your app is constrained to this space or namespace, let's say, or this pod or this node, then you can have as much access as you need. Is there any difference? Do you know what I mean? Does it make sense what I said?
So it's exactly the same thing as we had before. It's we need to make sure that applications have access to what they need and don't have access to what they don't need. Now, Kubernetes does make it easier because you can have network policies and you can apply those, and they're easier to manage than who knows what networking management tool that you'll have. Kubernetes also has pod security policies, which again, actually kind of federates this knowledge around my pod should be able to do this. So it should not be able to run its root. It shouldn't be able to do this. It shouldn't be able to do that. So it's still the same practice, Carly said, but the way that we can control it is now with a standard set of tools. We still have not cracked the whole nut, because the whole thing of turning auditing on to understand and then having great tools that can read audit logs from Kubernetes just still aren't there. And just to add one more last thing, that before we were at VMware and we were at Heptio, we had a coworker who wrote basically dynamic audit. And that was probably one of the first steps that we would need to be able to employ this at scale. So we are super early in our journey in getting this right. We just don't have all the necessary tools yet. So that's why it's hard, and that's why people don't do it.
I do think it is nice that that those primitives are available to people who are making use of that platform, though, right? Because it, again, kind of opens up that conversation, right, around transparency. If you have the goal being that, like, if you understood the tools that were defining that constraint, then at least you perhaps you have access to view what the constraints are, and understand whether they're actually rational or not with your application. So when you're trying to resolve, like, I have deployed my application in dev and it's the Wild West, there's no constraint anywhere, I can do anything within dev, right? And then when I'm trying to actually promote my application to staging, it gives you some platform around which you can actually, like, say, okay, well, when I get to staging, I do have to enforce these things, and I have a way, and again, it's all still part of that same API. I still have that same user experience that I had when just deploying or designing the applications and getting them deployed. I can still look at, again, and understand, like, what the constraints are that are being applied, and make sure that they're reasonable for my application. Does my application run as an en route? Does it have access to the network resources that it needs to? And if not, can I see where the gaps are?
So for anyone listening to this, Kubernetes doesn't have all the documentation we need, and no one has actually written this book yet. But on Kubernetes.io, there are a couple of documents about security. And if we have show notes, I will make sure those get included in our show notes, because I think there are things that you should you should at least understand what's in a pod security policy. You should at least understand what's in a network security policy. You should at least understand how roles and role bindings work. You should understand what you're going to do for certificate management. How do you manage a certificate authority in Kubernetes? How do you actually work these things out? And this is where you should start before you do anything else really fancy. At least understand your landscape.
Duffy did a TGAK talk on secrets. I think it was a series. There were a couple of them, Duffy.
Yeah, there were, and I need to get back and do a little more. But yeah,
we should add those to our show notes too. Hopefully, they actually exist, or I'm willing this into existence.
We are going to have show notes. Yes.
yeah.
All right.
Well, that is an interesting point. Like bringing up secrets and secret management, and also like security and things like that. There are some tools that exist that we can use now in the cloud native world, at least in the container world. Things like Vault exists. Things like now kubeadm, you can reroll a certificate, which is really nice. All these, like, we are getting to a place where we have more tooling available, and I'm really happy about it because I remember using Kubernetes a year ago, and everyone's like, well, how do you secure a secret in Kubernetes? And I'm like, well, it sure is base 64 encoded, and that's not at all secure.
Well, I will give credit. Bitnami has been doing sealed secrets. That's been out for quite a while. But the problem is that how are you supposed to know about that? And how are you supposed to know if it's a good standard? And then also, how are you supposed to benchmark against that? How do you know if all your secrets, how do you know if your secrets are okay? And we haven't talked about the other side, which is response or detection of issues. We're just talking about starting out. What do you do?
That's right.
Yeah, and it is tricky. Like we're saying, like understanding all the avenues that you could be impacted is kind of a daunting task. I mean, yeah. So let's talk about like the Target breach that occurred a few years ago. So if anybody doesn't remember this, basically Target had a huge credit card breach from their database. And, basically what happened is that their OIDC, if I recall properly, their OIDC agent or their token had not expired, but the audience for it was so broad that someone had hacked into one computer, essentially, like a register or something, and they were able to get the OIDC token from the local machine. And the authentication audience for that whole token was so broad that they were able to access a database that had all of the credit card information into it. And these are one of those things that sometimes you don't think about when you're setting up security, when you're just getting started or something like that. Like, what are the avenues of attack, right? And you would say, like, oh, OIDC is a secure authentication mechanism. How, why would we need to concern ourselves with this? And then, but not understanding kind of what we were talking about last week with the networking and the broadcast domain, what is the blast radius of something like this? And so, like, I feel like this is a good example of sometimes security can be really, really hard, and getting started can be really daunting.
Yeah, I agree. Yeah, I mean, getting started, and actually, and even I mean, to Brian's point, is like, how do you test against this? How do you know that what you've defined is enough, right? Like we can define all of these constraints, and we can even think that they're pretty reasonable or rational, and the application may come up and operate, but like, how do you know? Like, how can you verify that what you've done is enough?
Yeah.
And then also remember, so with OIDC has its foundations in OAuth, and you realize that it's a very strong door, but it's only a strong door. It also assumes that you can't walk around the wall that it's protecting or climb over the wall that it's protecting. And so there's a bit of trust. And when you get into things like the Target breach, you have to understand that you really have to understand blast radius for anything that you're going to do. So a good example would be if you're using shared key kind of things, or like public shared key, and you're using things like you have certificate authorities and you're generating certificates, you should probably have multiple certificate authorities. And you can have basically a hierarchy of these. So you could have basically the root one controlled by just a few people in security, and then each department can have their own certificate authority. And then you should also have things like revocation. You should be able to say that, hey, all this is bad, and it should all go away. And you probably should have revocation list, which a lot of us don't have, believe it or not, internally, where if I kill a certificate or a certificate that was generated and I put it in my revocation list, it should not be served. And our clients that are accepting that, are servers that see that, if we're using client-side certificates, we should reject those instantly. So really what we need to do is stop looking at security as this one big thing. And we need to figure out, what are our blast radius? A firecracker blowing up in my hand is going to hurt me, but Nick, is not going to hurt you. But, if someone drops a huge nuclear bomb on the United States, on the West Coast of the United States, I'm talking to myself right now. So we got to think about that. We got to think about it like that. What's the worst that can happen if this thing gets busted or gets shared, or someone finds it that should not have it? And every piece of data that you have that you consider secure or sensitive, you should be able to figure out what that means. And that's how, whenever you're defining a security posture, that's what you're doing. Because that's why you'll notice that a lot of companies, some of them do run open within a contained zone. So within this contained zone, you can talk to whoever you want. We don't actually have to be as secure here, because if we lose one, we lost them all. So who cares? So we need to think about that. And how do we do that in Kubernetes? Well, we use things like namespaces, first of all, and then we use things like this network policies, and we use things like pod security policies. We can lock some access down to just namespaces if need be. You can only talk to pods in your namespace. And what you need to do, and I'm not telling you how to do this, but you need to figure out, talking with, if you're a developer, talking with your security people. But if you're in security, you need to talk to your product management staff and your engineering, your software engineering staff, to figure out really, how does this need to work. So you realize that security is fun, and we have all sorts of neat tools depending on what side you're on. If you are red team, you're hacking in; you're blue team, you're saving things. We need to figure out these conversations, and tooling comes from these conversations, but we need to have this conversation first.
Yeah, I think, I feel like I'm a little bit of a broken record on this one, but I'm going to go back to chaos engineering again, because I feel like it's critical to stuff like this, because it enables a culture in which you can explore both the behavior of applications itself, but why not also use this model to explore different ways of accessing that information, or coming up with theories about the way the system might be vulnerable based on a particular attack or a type of attack, right? But I think that this is actually one of the movements within our space that I think provides like the most hope in this particular scenario, because like a reasonable chaos engineering practice within an organization enables that ability to explore all the things. You don't have to be red team or blue team. You could just be somebody who understands this application well. And the question for the day is, how can we attack this application? Let's come up with theories about the way that perhaps this application could be attacked. Think about the problem differently. Instead of thinking about it as an access problem, think about it as, think about it as the way that you extend trust to the other components within the cluster. Like, are they, or within your particular distributed system? Do they have access that they don't need? Can you use it as a, come up with a practice or come up with a theory around being able to, use some proxy component of another system to attack yet a third system. Start playing with those ideas and prove them out within your application. A culture that embraces that, I think, is going to be by far a more secure culture, because it lets developers and engineers explore these systems in real, in ways that we don't generally explore them.
Right, but also, if I could operate on myself, I would never need a doctor. And the reason I bring that up is because we use terms like chaos engineering, and this is no disrespect to you, Duffy, so don't take it as this panacea or this idea that will make us better. And true, that's fine. It will make us better. But the little secret behind chaos computing or chaos engineering is that it's hard. It's hard to build these experiments. First of all, it's hard to collect results from these experiments. And then it's hard to extrapolate what you got out of the experiment to apply it to whatever you're working on to repeat. And what I would like to see is more people in our space talking about how we can apply such techniques, but giving us, whether it's giving us more words or giving us more software that we can employ, because I hate to say it, it's pretty chaotic in chaos engineering right now for Kubernetes. Because if you look at all the people out there who've done it well, so you look at what Netflix has done with pioneering this, and then you listen to what a company such as like Gremlin is talking about. It's all fine and dandy, but if you have to realize that it's another piece of complexity that you have to own. And just like any other thing in security world, you need to rationalize how much time you're going to spend on it versus the bottom line. Because if I have a Hello World app, I don't really care about network access to that, unless it's a Hello World app running on the same subnet as doing some PCI data. Then it's a different conversation.
Yeah, I agree. I'm not, and I certainly am not trying to position it as a panacea. What I'm trying to describe is that I feel like having a culture that embraces that sort of thinking is going to enable us to be in a better position to secure these applications, or to handle a breach, or to deal with very hard to understand or resolve problems at scale. Whether that's a number of connections per second, or whether that's the number of applications that we've horizontally scaled. Like coming up with being able to embrace that sort of a culture where we ask why, or we say, well, what if, or if we actually come up, embracing the idea of that curiosity that got you into this field. You know what I mean? Like, right. I think that so frequently our cultures are opposite that, right? It becomes a race to the finish. And in that race to the finish, lots of pieces fall off that we're not even aware of, and that's what I'm highlighting here when I talk about it.
Yeah, so it seems like maybe the best solution to the dichotomy between security and agility is really just open conversation in a way. Yeah. People actually reaching across the aisle. Well, that's not a great phrase, but whatever. To talk to each other. So if you're embracing this culture, as you're saying, Duffy, the security team should be having constant communication with the application team, instead of just the application team doing something wrong and the security team coming down and smacking their hand and being like, no, you can't do it this way because of our draconian rules, right? It's these people working together and kind of almost playing together a little bit inside of their own environment to foster a better environment. And I'm sorry, I didn't mean to cut you off there, Brian.
Oh no, that thought was fleeting, like all my thoughts. But to say more about what you're saying is that it's not just more conversations, because we can still have conversations, and I'm talking about CIDR and subnets and attack vectors and buffer overflows and things like that. But my developers are talking, well, I just need to be able to serve this data so accounting can do this. And that's what happens a lot in security conversations. You have two groups of individuals who have wholly different goals. And part of that conversation needs to be aligning on jargon and then aligning on those goals. What happens with pretty much everything in development world, we always bring our networking, our security, and our operations people in right at the end, right when we're ready to ship. Hey, make this thing work. And really, that's where a lot of our problems come out. Now, security either could or wanted to be involved at the beginning of a software project where we actually are talking about what we're trying to do. We're trying to open up this service to talk to this, share this kind of data. Security can be in there early saying, oh, no, we're using this resource in our cloud provider. It doesn't really matter what cloud provider, and we need to protect this. This data is sitting here at rest. If we could get those conversations earlier, it would be easier to engineer solutions that could be hopefully reused, so we don't have to have that conversation in the future.
But then it goes back to the issue of agility, right? Like Duffy was saying, well, you can develop on a development cluster, which has much less restrictions. Can you believe I said that? It has much less restrictions, and then move to a production environment with the proper restrictions, and then you find out, or maybe a staging environment, let's say, and then you find out, oh, whoops, there are a bunch of restrictions I didn't deal with, but I did move a lot faster because I didn't have them, but now I have to deal with them.
Yeah, I do think it's important to have a kind of a promotion model in which you are able to move toward a more secure deployment, right? Like, because I do think when you're thinking, it's like people frequently also, I guess a parallel to this is like, I've heard it said that you should develop your monolith first, and then when you actually have the working, when you actually have a working prototype of what you're trying to create, you should then consider carefully whether it's time to break this thing up into a set of distinct services, right? And consider carefully also like what the value of that might be, right? And I think that the reason that that's said is because it is easier. It's maybe like a lower cognitive load with everything's all right there in the same code base. You understand how all these pieces interconnect, and you can kind of like, and you can quickly develop or prototype what you're working on. Whereas if you're trying to develop all of these things into individual microservices first, it's harder to figure out where the line is, like where to divide all of the business logic up. I think this is also important when you're thinking about the security aspects of this, right? Like being able to do a thing in which you are not constrained, define all of these services and your application and the model for how they communicate without constraint is important. And once you have that, once you actually understand what normal looks like for that set of applications, then enforce them, right? Like if you're able to declare that intent, you're able to say like, these are the ports I'm going to list on for these things. These are the things that they're going to access. These are the way that they're going to go about accessing them. If you can declare that intent, then that's actually that's a reasonable body of knowledge for which the security people can come along and say, okay, well, you've told us, you've informed us, you've worked with us to tell us like what your intent is. We're going to enforce that intent and see if it's reason and see what falls out, and we can iterate there.
Yeah, everything you said makes sense to me. Starting with build a monolith first. I mean, when you start out, why would you want to abstract things that you don't really? I mean, you might think you know, but you only really know in practice what you're going to need to abstract. So don't abstract things too early. I'm a big fan of that idea. So yeah, start with the monolith, and then you figure out how to break it down based on what you need. With security, I would imagine the same idea resonates with me. Don't secure things that you don't need. You don't know just yet that need securing, except the deal breaker things. Like there are some things we know, like we don't want production data being accessed. Some types of production data. Some things we know we need to secure. So from the beginning.
Right, but I would still iterate that it's always it's deny by default. Just remember that it's security. It's actually the opposite way. We want to make sure that we have the least amount, and even if it is harder for us, you always want to start with I allowed TCP communication on port 443 or UDP as well. That's what I would allow, rather than saying, oh, we have, rather than saying shut everything else off but this, I'd rather have it the other way, that we only allow that. And that also goes in with our declarative nature and cloud native things that we like anyways. We just say what we want, and everything else doesn't exist.
I do want to clarify though, because I think you and I we are like representative of that dichotomy right at this moment, right? Like I feel like what you're saying is that like the constraint should be the normal. Being able to drop all traffic, do not allow anything, is normal, and then if you have to declare intent to open anything up, And what I'm saying is, frequently developers don't know what normal looks like yet. They need to they need to be able to explore what normal looks like by developing these patterns, and then enforce them. Right, which is kind of turning the model on its head, and this is actually, I think, the kernel that I'm trying to get to in this conversation is that, like, there has to be a place where you can go play and learn what normal is, and then you can move into a world in which you can actually enforce what that normal looks like with reasonable constraint. But until you know what that is, until you have that opportunity to learn it, all we're doing here is restricting your ability to learn. We're adding friction to the process.
Right. And I think, I think what I'm trying to say here, layer on top of this, is that, yes, I agree, but then I understand what a breach can do, and what bad security will do. So I'll say, yeah, go learn, go play all you want, but not on software that will ever make it to production. Go learn those practices, but you're going to have to do it outside of, you're going to have a sandbox, and that sandbox is going to be unconnected from the world. I mean, from our world at least. And you're going to have to learn, but you're not going to practice here. This is not where you learn how to do this.
Exactly right. Yeah. Yeah. You don't learn to ride a motorcycle on the street. You learn to ride a motorcycle on the dirt, and then you could take those skills later, but yeah, I think we're in agreement. Like, production is a place where we do have to enforce all of those things, and having some promotion model in which you can come from a place where you've learned it to a place where you're beginning to enforce it to a place where it is enforced, I think is also important. And I frequently describe this as like development, staging, and production, right? Staging is where you're going to hit the edges, because this is where you're actually defining that constraint, and it has to be right before it can be promoted to production, right? And I feel like that middle ground is also important.
And remember that production is any environment production can reach. People
That's right.
Any environment that can reach production is production, and that's including, hey, we do data backup dumps, and we clean them up from production, and we use it as data in our staging environment. If production can directly reach staging or vice versa, it's all production, and that's how your attack vector. That's your attack vector. That's how someone's going to get in and steal your production data.
That's absolutely right.
Google actually makes an interesting kind of, not caveat to that, but like side point to that, where, like, if I understand the way that Google runs, they run everything in production, right? Like dev, staging, and production are all the same environment. I'm more positing this is a question because I don't know if any of us have the answer, but I wonder how they secure their infrastructure, their environment well enough to allow people to play, to learn these things, and also to deploy to production level code all in the same area. And that seems really kind of interesting to me. And if I understood that, I'd probably be making a lot more money.
Well, it's simple, really. There's a huge people process at Google that acts as gatekeeper for a lot of this stuff. So I have never worked at Google. I have no intrinsic knowledge of Google or have talked to anyone who is giving me this insight. This is all speculation, disclaimer over. But you can actually run a big cluster that, if you can actually prove that you have network and memory and CPU isolation between containers, which they can in certain cases. In certain cases, they can do this. What you can do is you can use your people process and your approvals to make sure that software gets to where it needs to be. So you can still play on the same clusters, but we have great handles on network that you can't talk to these networks, or you can't use this much network data. We have great things on CPU that this CPU would be PCI data. We will not allow it unless it's tagged as CPU as PCI. Once you have that in place, you do have a lot more flexibility. But to do that, you will have to have some pretty complex approval structures and then software to back that up. So the burden on it is not on the normal developer. And that's actually what Google has done. They have so many tools and they have so many processes where if you use this tool, it actually does the process for you. You don't have to think about it. And that's where we want our developers to be. We want them to be able to use our either our networking libraries, or whenever they're building their containers or their Kubernetes manifest, use our tools, and we will make sure, based on either inspection or just explicit settings, that we will build something that is as secure as we can, given the inputs.
Mm.
And what I'm saying is hard, and it's capital H hard. And I'm actually just painting where we want to be, and where a lot of us are not. Most people are not there.
Yeah, it would be nice if we had, like we said very early, like more tooling around the security and the processes and all these things. One thing I think that people seem to bulk on, at least I feel, is developing it for their own use case, right? It seems like people want a overarching tool to solve all the use cases in the world. And I think with the rise of cloud native applications and things like container orchestration, I would like to see people more developing for themselves and their own processes around Kubernetes and things like that. I want to see more perspective into how people are solving their security problems, instead of just like relying on, let's say, like HashiCorp or like Aquasec to provide all the answers. Like I want to see more answers that people are doing.
Well, it's because tools like Vault are hard to write and hard to maintain and hard to keep correct. Because you think about other large competitors to Vault, and they are out there, like tools like CyberArk. I have a secret, and I want to make sure only a certain number of people can keep it. That's a very difficult tool. But the HashiCorp advantage here is that they've made tools to speak to people who write software or people who understand ops, not just as a checkbox. It is not hard to get, if you're using Vault, it is not hard to get a secret out if you have the right credentials. Other tools, it's super hard to get the secret out if you even have the right credential, because they have a weird API, or they just make it very hard for you, or they expect you to go click on some GUI somewhere. And that's what we need to do. We need to have better programming interfaces and better operator interfaces, and which extends to better security people interfaces for using these tools. This actually is and I don't know how well this works in practice, but the Jeff Bezos, how teams at AWS or Amazon are formed. Teams communicate on an API. And I'm not saying that we shouldn't talk, but we should definitely make sure that our APIs between teams, and like team who own security stuff and teams who are writing developer stuff, that we can talk on the same level of fidelity that we can having a in-person conversation. We should be able to do that through our software as well, whether that be for asking for ports or asking for more resources, or just talking about a problem that we have. That's my thought leadering answer to this. This is Brian wants to be a VP of something one day, and that's the answer I'm getting. I'm going to be a CIO. That's my CIO answer.
I like it. So cool.
Well, is there anything else on this subject that we wanted to hit? I know we've gone almost an hour here.
Yeah, I think we've actually kind of touched on pretty much everything. Like we got a lot out of this, and I'm always impressed with the direction that we go. I did not expect us to go down this route, and I was very pleased with the discussion that we've had so far.
Me too. I think that I think if we were going to explore anything else, we'd talk about kind of get it more into that state where we're talking about like that we need more feedback loops. We need people, developers to talk to security people. We need security people to talk to developers. We need like some way of actually bridging that feedback loop, much like some of the other cultural changes that we've seen in our industry are trying to allow for better feedback loops in other spaces. And you brought up DevSecOps, which is another kind of another move to try and kind of like open up that feedback loop. But the problem I think is still going to be that even if we improve that feedback loop, we're kind of in an age where, especially as you get into some of the larger organizations, there are too many applications to solve this problem for, and I don't know yet how to address this problem in that context, right? If you're in a state where you're a 20-person, 30-person security team, and your responsibility is to secure a platform that is running a number of Kubernetes clusters, a number of vSphere clusters, a number of cloud provider implementations, whether they be AWS or GCP. Like, I mean, that's a set of problems that is very difficult, and it's like I'm not sure that improving the feedback loop really solves it. I know that it helps, but I definitely, I have empathy for those folks for sure.
Yeah.
Security is not my forte at all, because whenever I'm developing, I have a very narrow needs. I have to access a cluster, I have to access a machine, or I have to be able to access a database, and it's usually not a no-brainer. But I get a lot of the issues that were brought up, but as a builder of software, I have empathy for people who use software, consume software, mine and others, and how can they have any visibility in as far as security goes? And for example, in the world of cloud native, let's say you're using Kubernetes, I sort of start thinking, well, shouldn't there be a scanner that just lets me declare? I think I'm starting an episode right now. Shouldn't there be a scanner that lets me declare, for example, this node can only access this set of nodes, sort of like a graph. But you just declare, and then you run it periodically, and you make sure. Of course, this goes down to like part of an app can only access part of the database. It can get very granular, but maybe at a very high level. I mean, how hard can this be? For example, maybe a name like this pod can only access that pods, but this pod cannot access this namespace, and just keep checking. What if the namespace changes, the permission changes? Or for example, with Velar, only these users can do a backup because they are the same users who will have access to the restore, so they have access to all the data. And you know what I mean? Just keep checking that is in place, and it only changes when you want to.
So, I mean, I know we're at the end of this call, and I don't want to start a whole new conversation, but this is why there are applications like Istio and Linkerd. This is why people want service meshes, because they can turn off all network access and then just use the service mesh to do the communication, and then they can make sure that it's encrypted on both sides and that it's authenticated on both sides.
Well,
that's why this software.
We're definitely going to have an episode or multiple on service mesh.
Yeah.
But we are at the top of the hour. Nick, do your thing.
All right. Well, thank you so much for joining us on another interesting discussion at the Podlets podcast. I've been Nicholas Lane. Duffy, any final thoughts?
It's a whole lot to discuss. I really enjoyed our conversations today. Thank you, everybody.
Brian?
It was good being here. Now it's lunchtime.
And Carlicia.
I love learning from you all. Thank you. Glad to be here.
Yeah, totally agreed. Thank you again for joining us, and we'll see you next time. Bye.
Bye.
Bye.